Welcome to substitution. Let's begin. Okay, y equals x squared. Y equals x plus 2. Think about it. If y equals x squared and y equals x plus 2, that means x squared must equal y and x plus 2 equals y. Therefore, if both of these things equal y, then they must equal each other. So here's how we're going to set it up. X squared equals x plus 2 because they equal each other, because they both equal y. Okay, you get that. X squared equals x plus 2. What we're going to do when they come for you. All right, so we're going to minus x squared. That would leave us with 0 equals minus x squared, or negative x squared, plus x plus 2. Okay, you can tell that this looks very similar. This is a quadratic equation. This is a quadratic, at least some kind of quadratic form at least. So negative x squared plus x plus 2. What we're going to do when they come for you, I'll tell you what we're going to do. We're going to put this into an x factor. Not an x-min, but an x factor. So we're going to draw our big X, and then a times c, which is negative 1 times 2 equals negative 2. And then our b, which is 1, because the 1x, because if you don't remember, in the quad right here is a, b, and c, right? A, b, c, d, e, f, g. All right, I don't have time for that. Anyways, okay, negative 2 and 1. So now on the sides of the x, we must figure out what times what equals negative 2, but also, when added together, equals 1. So, number times number equals negative 2, and that same number times number, or not times, but plus number equals 1. What are the two numbers? I'll give you 1 second. Times up. The numbers are 2 and negative 1. So 2 times negative 1 equals negative 2. 2 minus 1, or 2 plus negative 1, equals 1, right? So now we have that. But we're not done with the x factor. We have to we have to put a underneath those two numbers. In this case, a is negative 1. So that means 2 over negative 1 and negative 1 over negative 1. Well, in math, they don't like you to have negatives in the denominator, so we must fix that. So let's bring this down here so we have more space. So 2 over negative 1. How do we get rid of that? Well, I'll tell you. We have to get rid of that denominator. And the way that we get rid of the denominator, or the negative in the denominator, is by timesing it by the denominator. So, how we do that? We times by negative 1 and negative 1, and that equals negative 2 over 1. Negative 2 over 1. So now we know that that factor is negative 2 over 1. And this one, with negative 1 over negative 1, negatives cancel out, so that means it's 1 over 1. So, we have 1 over 1 and negative 2 over 1. Now, we must put this in the factor form. So, I'm going to erase this right here, and let's put this into factor form. Okay, so, if you don't remember, I'll re-explain. How do we do this? All right, so the bottom number of each of these fractions represents the x. So, for this case, with negative 2 over 1, that would be x minus 2. Because the bottom equals, or it represents the x, and whatever's on top is what it is. You just add it after the x. So, x minus 2. And then for 1 over 1, it'd just be x plus 1. But we're not done. We have to do something to this so we can actually get our real factors. And here's how we do it. Instead of in parentheses, we're going to take away the parentheses. We're going to do x minus 2 equals 0. And x plus 1 equals 0. Okay, so now we're going to distribute that over. So that's x equals 2. Distribute that over, and that is x equals negative 1. Okay, x equals 2 and x equals negative 1. Now we have our x's. We have half of the problem. We have half of the 2 points that we are looking for right now. So what do we do now? What do we do? Next, we must find the y values. So what I'm going to do is I'm going to erase a bunch of this mumbo jumbo that we don't need anymore. We don't even need the factors. We need the factors, but we don't even need the factor form. We just need x equals 2 and x equals negative 1. All right, so now what do we do? How do we get this y value? Think about it. If x equals 2 and x equals negative 1, that means we can still plug this into these original equations. So what we're going to do is we're going to pick one of these equations and we're going to plug in the x's. It's not COVID, I promise. All right, so we're going to choose the first one because it's a lot easier than the second one. Why is that? Because it is. Okay, so the first one, y equals x squared. Let's plug it in. Y equals, we're going to use the 2 squared. Y equals, we're going to use the negative 1 squared. Okay, What does 2 squared equal? It equals 4. What does negative 1 squared equal? It equals 1. Okay, now we know that 4 and 1, these are our y values. 4 and 1 are our y values. So now how do we piece this together? How do we piece the x and the y? I'll tell you how. We use the 2, which is an x, and we end up getting a 4, which is the y. Therefore, that would be 2, 4. We use the negative 1, which is x, and it resulted in a normal or positive 1, which is y, and that would be negative 1, 1. You get what I'm saying there? Okay, good. You bet it. So, 2, 4, and negative 1, 1. Those are our solutions. And I know that there are solutions because y equals x squared, which also equals x plus 2. So these have to be our solutions right here, these 2 points. But what we're going to do, just because Mr. Sanders would want me to, and I really want to make a good grade on this, we are going to go a little bit further, and we're going to prove that these 2 points are the only 2 solutions. Let's do that. So I'm going to write the equations back up here again. Y equals x squared and y equals x plus 2. Now here's what we're going to do. How can we do this, Caleb? I don't know. Well, I'll tell you. What we're going to do is we're going to end up making an H chart. If you watched the graphing video, then you would know what the H chart is. It's basically an H in a chart form. Okay, H chart. We have x, y1, and y2. In this case, y1 is going to represent this equation, and y2 is going to represent the bottom equation. So, what do we do next? We're going to plug in some x values and see what our outputs are going to be. Here's what I've decided to do. What we're going to do is we're going to start, our starting x value is going to be one number before our range of these 2 points. And we're going to end with one number after our whole range of these points. Let me explain. All right, so we have 2, 4, and we have negative 1, 1. Let's start with negative 2, negative 1, then 0, 1, 2, 3. Negative 2 is 1 before the negative 1 x value in this point, which is the lowest x value that we have in this situation whenever it comes to these 2 solutions. And then 3 is 1 past the number 2, which is the highest x value that we have out of these 2 points. So, negative 2, negative 1, 0, 1, 2, 3. So, what do we do now? It's very simple. What's the output? How do we get it? Well, we do the same thing we did earlier. We plug these numbers in. Y1, remember, equals this top, or represents this top equation, right? So let's plug in negative 2. Let's see what Y1 becomes. Negative 2 squared equals 4, right? You put the negative 2 there, and you square it, that equals 4. Negative 1 squared equals 1. 0 squared equals 0. 1 squared equals 1. 2 squared equals 4. 3 squared equals 9. So those are all of our y outputs for the top equation. Now let's go to the second equation, which is represented by y2, meaning we're going to start plugging in all of these x values into the second equation. So y equals negative 2 plus 2, that is 0. All right, negative 1 plus 2, that is 1. 0 plus 2, that is 0. 1 plus 2 is 3. 2 plus 2 is 4. 3 plus 2 is 5. It's 5. Okay. We filled out the chart. So now you may be thinking, why? Like, what does this even mean? How does this even, what are you even talking about, Caleb? Well, if you watched the last video, you'd understand that this x is not talking about the x-axis. This y is not talking about the y-axis. This is a point. This is a point system. This chart is a point-based chart. So how would we write out some of these points? Let's use the first one for example. Okay, so this right here, negative 2, 4, and 0, how would we write that out? For the top equation, that would be negative 2, 4. For the bottom equation, it would be negative 2, 0. Because, you know, both of them have the same x, they just have different y's, right? Okay, using that knowledge, what we need to do is, I want you to look for a pattern. Look for a pattern within the y values. Within the y values. Because think about it. Every single one of these points, whenever they all share the same x value. Whenever it comes to y1 and y2, they all share the same x value. So what we need to find is a pattern of the y value. The y value. Can we find the same types of y value? You'll see what I mean in a second. Let's look at the first one. -2, 4, and 0. Are 4 and 0, are they the same thing? No. That's not a solution. -1. 1 and 1, are those the same y values? Yes. 0, 0, 2. Is 0 and 2 the same value? No. 1, 1, 3. Is 1 and 3, are they the same y value? No. 2, 4, 4. Are 4 and 4 the same value? Yes. 3, 9, 5. Is 9 and 5 the same value? No. They're not. -1, 1, 1, 2, 4, and 4. What does this mean? If we use the knowledge that I just gave you a second ago, then we would understand that these two thingamajigs on this table will show us that these are the two solutions. Let me show you how. Let's look at this one, for example. For x and y1, x, y1, that equals -1, 1. All right, now let's look at x and y2. X and y2 equals -1, 1. Same point. Therefore, they're intersecting. They're hitting at the same point. That means that, and basically what that means is it's a solution. This is solution, okay? Now, let's look at, what's another one? All right, let's look at 2, 4, and 4. All right, so I'm going to erase this real quick. I'll just erase this top half because I want to. Okay, x, y, 1, y2. All right, so now let's look at this. Okay, let's look at this row right here, or column, whatever you want. It's a row, actually. It's not a column. It's a row. I know my stuff. Okay, so x, y1 equals what? 2 and 4. X and y2. X and y2. That equals 2, 4. They are the same, so it's a solution. Out of this whole entire list, these are the only two solutions that we find. Therefore, that means that 2, 4 and -1, 1 are most definitely and absolutely solutions. And the only two solutions. Therefore, this means not only are these the two solutions, but that this problem is a two-solution answer. That's all, folks.